Venus takes 243 Earth days to complete a single rotation. Its year is only 224.7 of those same days. Read that again, slowly. The orbit ends before the spin does. Venus travels all the way around the Sun, the entire loop, before it manages to turn around once on its own axis. The day is longer than the year, not as a figure of speech, not as a rounding error in some old almanac. It is a measured, confirmed, physical fact about a neighbour of our own planet, a world that has hung in our sky for as long as anyone has looked up. Stand on that surface if you could somehow survive it. Survive air that sits at 464 degrees, hot enough to melt lead. Survive a pressure of 93 atmospheres, the same crushing weight you would feel nearly a kilometre beneath the surface of Earth's ocean. If you could endure all of that and simply look up, you would watch the sun rise in the west and set in the east. The wrong way, the backward way, because Venus does not spin like the other planets. It turns clockwise, against its own orbit, against the grain of almost everything else in the solar system. And Venus is not alone in its strangeness. Travel inward toward the sun, to the small scorched world of Mercury. There a single solar day, one sunrise to the next, lasts 176 Earth days. That is exactly 2 Mercury years. The calendar and the clock have collapsed into one another. Near the point in its orbit where Mercury swings closest to the Sun, something happens that should not be possible. The Sun climbs above the horizon, slows, stops, reverses, sinks back down below the edge of the world, and then rises a second time. A double sunrise, witnessed inside a single day. 2 worlds, 2 completely different sets of physics driving them. The same impossible outcome. Here is what that should quietly break open inside you. The day, the single most basic unit of time that every civilization in all of human history has ever built a calendar around, is not a law of the universe. It was never handed down from anything. It is a local accident, an artifact of which particular rock you happen to be born standing on. Somewhere else, under a different sky, the day and the year trade places, or fold into each other, or stretch into shapes no human clock was ever designed to measure. We treat time as if it were the most solid thing we have, the one fixed beam the rest of reality hangs from. The sun comes up, the sun goes down, and we call that span a day, and we are certain, deep in our bones, that this is simply how time works. It is not how time works. It is how time works here, on this one warm and gentle planet, for now. Move the observer somewhere else, and the entire architecture of time bends with them. That is what the next few hours are for, to follow that bend all the way down. To understand exactly how a world can finish its year before it finishes its day, and why 2 neighbours of ours arrived at that same near impossibility by 2 entirely separate roads. To see how astronomers spent the better part of a century convinced they understood these planets, and how a single new kind of measurement quietly proved every one of them wrong. And to sit, for a while, with the strange and steadying truth that the most ordinary thing you know, the simple passing of a day, is far stranger than it is ever let on. If you enjoy slow, careful journeys through the real physics of the worlds around us, do me a small favour and tap that like button and subscribe. It genuinely helps this channel grow, and it lets me keep making these long, quiet deep dives for you. So settle in, lower the lights, make yourself warm and comfortable, and let go of the day you have been carrying. Let's begin. To understand how strange these 2 worlds really are, you first have to understand how long it took us simply to measure them. For almost the whole of human history, Venus was the brightest object in the sky after the sun and the moon. And yet it was also among the most misread. People watched it for thousands of years. They named it the morning star and the evening star, 2 separate lights with 2 separate names, long before anyone understood that both were the same single world. For all of that watching, Nobody could answer the plainest question you can ask about a planet. They could not tell you how fast it turned. The first real crack in that ignorance opened in the year 1610. In that year, a man in northern Italy named Galileo Galilei lifted a newly built telescope toward Venus and saw something no human eye had ever resolved before. He saw that Venus had phases. Exactly like the moon, the planet swelled from a thin sliver of crescent to a full bright disk, and then thinned back again, a complete and repeating cycle of light and shadow. This was not a minor curiosity. It was a quiet catastrophe for nearly everything people believed about the heavens. A Venus that ran through a full sequence of phases could not possibly be circling the Earth in the way the old models insisted. It could behave that way only if it orbited the Sun. By the year 1613, that single observation was being offered as decisive proof that the Earth was not the still centre of all things, that our world was merely one of several moving around a central fire. Here is the first of many places where this story folds back on itself. Galileo had proven how Venus moves through space. He had not, and with his instrument could not, prove how Venus moves upon its own axis. Those are two entirely different motions. One is the long journey around the Sun. The other is the turning of the world beneath its own sky, the spin that carries a point on the surface from darkness into daylight and back into darkness again. The telescope had revealed the first motion beautifully. For the second, it was very nearly useless. To measure how fast a planet spins, you have to watch some fixed feature on its surface drift across the face of the disk. A mountain, a dark stain, a marking of any kind, and time how long it takes to come all the way back around. On Mars, astronomers could do precisely this. On Venus, they saw nothing. Nothing at all. The reason is the very thing that makes Venus so lovely to look at. Venus is wrapped, completely and permanently, in cloud. A thick, unbroken shell of it, brilliant and featureless, reflecting sunlight so efficiently that the planet burns like a lamp in the twilight. Those clouds are not made of water, they are droplets of sulfuric acid, though no observer in the 17th or 18th or 19th century had any way of knowing that. What they knew was simpler and far more maddening. When they aimed the finest instruments they could build at Venus, they saw a smooth blank globe of light, carrying no reliable, permanent marking anywhere across its surface. There was nothing to time, there was nothing to track. The ground of the planet, and with it the whole truth of its rotation, lay sealed away behind a veil that simply refused to lift. So astronomers did what careful people always do when the evidence runs dry. They reasoned. In the closing years of the 19th century, one of the most respected observers then alive reasoned his way toward an answer that felt elegant and sensible and very nearly certain. His name was Giovanni Schiaparelli, and he worked at the observatory in Milan. Between the years 1889 and 1891, Schiaparelli studied Mercury, the small swift world closest to the Sun, and concluded that it had to be tidally locked. He proposed that Mercury held one single face turned toward the Sun at all times, the way the Moon holds one face turned forever toward the Earth. One hemisphere in everlasting day, one in everlasting night. Then he carried the same logic outward and laid it over Venus as well. It was a thoroughly reasonable leap. The Sun's gravity, he argued, would have gripped these inner worlds across the long ages and slowed their spinning until each settled into perfect step with its own orbit, turning exactly once for every single circuit around the Sun, presenting the same hemisphere to the central fire forever. For Venus, hidden behind its clouds and impossible to measure directly, this was not merely a guess, it was the default. It was what the physics of the day appeared to insist upon. So for the better part of the following century, the textbooks carried it as something close to settled fact. Venus, they said, was a synchronous world, one face scorched in perpetual day, the other sealed in perpetual freezing dark. That answer was wrong, not slightly wrong, in the way an estimate might run a little too high or a little too low. It was wrong at the foundation, wrong about the most basic fact of the planet's existence. Venus is not tidally locked. Venus does not keep one face toward the sun. The truth, when it finally arrived, turned out to be so much stranger than the tidy picture it replaced that it took an entirely new way of seeing to drag it into the open. That new way of seeing was radar. Not a larger telescope, not a finer lens, but something that did not depend on visible light at all. The idea behind it was as bold as it was simple. If you cannot see the surface of Venus, then stop trying to see it. Send a pulse of radio energy out across tens of millions of miles of empty space. Let it strike the planet, and listen patiently for the faint echo that comes back. Radio waves do not care about clouds. They slip straight through that sulfuric veil as though it were not even there, reflect off the solid ground beneath, and return carrying information no telescope on Earth could ever gather. The first serious attempt came in the year 1961, during a close approach of Venus to the Earth. 3 separate groups, scattered across different parts of our planet, aimed their instruments at Venus and waited for the echo to come home. There was a 26-meter antenna at Goldstone, out in the California desert, operated by the Jet Propulsion Laboratory. There was the Great Dish at the Jodrell Bank Radio Observatory in England. There was a Soviet facility at Yevpatoria, on the Crimean Peninsula. For the first time in all of human history, people were no longer merely looking at Venus. They were reaching out and touching it, throwing a beam of radio light across the void, and feeling for the shape of whatever came back. What came back rewrote the textbook by reading the way the echo was stretched and smeared, the way different parts of the spinning planet nudged the returning signal by tiny measurable amounts. The astronomers could finally clock the rotation itself, directly, for the very first time. The planet was not locked at all. It was turning. Slowly. Almost unbelievably slowly, but unmistakably turning. From the observations gathered in 1962, a far stranger conclusion began to surface. One so unexpected that it demanded 2 more years of painstaking work before anyone dared trust it. By 1964, the result was confirmed, and it was this. Venus does not spin the way the other planets spin. Venus spins backward. If Venus had quietly embarrassed the old certainty, Mercury was about to finish the demolition. Through all the decades that Schiaparelli's locked world had stood unchallenged in the textbooks, Mercury too had been waiting to be measured by something better than the human eye. In the year 1965, astronomers turned radar on Mercury as well, bouncing a signal off the innermost planet and reading its echo by the same method that had unmasked Venus. Mercury, exactly like its cloud-wrapped neighbour, was not doing what everyone had sworn it must. It was not holding one fixed face to the sun. It was turning 3 times for every 2 journeys it made around the sun. A precise and delicate rhythm no one had imagined, and no telescope could ever have exposed. 76 years of confident astronomy, the patient work of careful people reasoning carefully from the best evidence they possessed, unravelled in the span of a handful of measurements. This is the pattern worth carrying with you as we go deeper. Again and again, with both of these worlds, the confident answer and the true answer turn out to be near strangers to each other. The eye handed us one story, the radio echo handed us another. The distance between those 2 stories is not a distance of small detail or fine adjustment. It is a distance of kind. The eye told us Venus was still. The echo told us Venus was crawling backward through its own sky. The eye told us Mercury faced the sun forever. The echo told us Mercury was counting out a quiet 3 against 2 rhythm that no human clock had ever been built to keep. Every time we believed we had finally pinned these planets down, they slipped the description entirely, and the real behavior underneath proved more peculiar than the mistake we had been making about it. Consider how recently all of this arrived. The campaign that finally caught Venus in the act of turning began in the year 1961, during one of the planet's close approaches to Earth. 3 separate teams, on 3 separate corners of the world, aimed their instruments at the same veiled point of light. At Goldstone, in the high desert of California, engineers from the Jet Propulsion Laboratory pointed a 26-meter antenna toward Venus and waited for the faint return of their own transmitted pulse. In the English countryside, the great dish at the Jodrell Bank Radio Observatory listened for the same thing. And far away in Crimea, at the Soviet facility near Yevpatoria, a third team chased the identical answer across the political chasm of the age. None of them could see the surface. None of them needed to anymore. The method was beautiful in its simplicity. They sent a pulse of radio energy hurtling across the gulf between the two worlds. They waited the long minutes it took for that pulse to cross the distance, strike the hidden rock below, and come limping back as a whisper of its former strength. Then they studied how the returning echo had been smeared and stretched. One limb of the planet was rotating toward them. The opposite limb was rotating away. That tiny difference in motion shifted the frequency of the reflection, spreading a sharp pulse into a broadened band, whose very width encoded the speed of the spin. Venus could hide its face behind its permanent veil of sulfuric cloud. It could not hide the fingerprint its own rotation pressed into the echo. Not the cloud, not the darkness, not the distance could erase it. By the year 1962, the verdict was taking shape, and it was an answer nobody had ordered. Venus was not standing still, as Schiaparelli had insisted. Venus was not turning in the familiar direction either. Venus was rotating backward, slowly, against the grain of nearly every other world in the Sun's family. The result was so strange that it took 2 further years of patient checking before the wider community would fully embrace it. Not because the measurements were doubtful, the measurements were clean, but because the conclusion demanded that everyone surrender a picture they had carried in comfort for the better part of a human lifetime. By the year 1964, the backward spin had passed from suspicion into settled fact. And what a spin it was. Relative to the distant stars, Venus takes roughly 243 Earth days to complete a single rotation. Its journey around the Sun takes only about 225. The turning is slower than the orbiting, but because the planet spins backward as it circles, the Sun appears to swing across its sky faster than the bare rotation would suggest, so that the interval from one sunrise to the next lasts close to 117 Earth days. Work the arithmetic through, and a quiet absurdity falls out. A single Venusian year contains fewer than 2 sunrises. Stand on that surface if you somehow could, and you might wait the equivalent of months of earthly time for the sky to brighten even once. Then came Mercury, and the second blow landed in the year 1965. Radar astronomers turned the same listening technique on the innermost planet, the very world Giovanni Schiaparelli had declared frozen-faced toward the Sun more than 7 decades earlier. The echo returned a number that fit none of the tidy old stories. Mercury was not locked at all. Mercury turned exactly 3 times for every 2 circuits it ran around the Sun, a rhythm so precise that it amounted to a kind of music no one had thought to listen for. 3 rotations, 2 orbits, a single rotation against the stars lasting near to 59 Earth days, an orbit lasting 88, and a day from sunrise to sunrise stretching to 176. 76 years of confident textbook astronomy dissolved in the reading of one instrument. The strangeness was not yet spent. In the year 1966, the radar returns from Venus produced one final oddity that edged toward the uncanny. Each time Venus swept closest to Earth, at the alignment astronomers call inferior conjunction, the planet presented very nearly the same face toward us, not by any obvious law, not by any rule that plainly demanded it. And yet there it was, a near repetition, holding across encounter after encounter, as though Venus were quietly keeping time with a neighbor far across the dark. The rotation period responsible for the effect came to roughly 243 days, the same ponderous slowness we started from. Some researchers went so far as to suggest that Earth itself, with its small and distant gravitational tug, might be helping to hold Venus gently in that beat. Notice how tightly these revelations cluster in time. 1961, the first echoes. 1962, the backward turning of Venus emerging from the noise. 1964, that backward turning confirmed beyond reasonable doubt. 1965, Mercury's 3:2 rhythm laid bare. 1966, the eerie way Venus keeps facing Earth. In the space of half a single decade, two of our nearest neighbours were stripped of the identities astronomy had assigned them for generations, and handed back to us transformed. A child born at the start of that decade was not yet old enough to read by the end of it. That is how fast and how recently the picture changed. Now step back and take in the shape of the whole story. For nearly the entire span of human history, we measured these worlds with the only instrument we had, which was light gathered by the living eye. Galileo Galilei, squinting through a crude telescope in the year 1610, watched Venus move through a full sequence of phases like a miniature moon, and from that alone he showed that it must circle the sun rather than the Earth. Within a few years, that single observation helped topple the entire ancient architecture of the heavens. It was a triumph. It was also, in truth, the easier half of the problem. Learning that Venus orbits the sun took one brilliant mind and a handful of clear nights. Learning how Venus turns upon its own axis took another 3 centuries and a half, a network of radio dishes scattered across rival nations, and the humility to be told the obvious answer had been wrong from the start. And the wrong answer was not held lightly. It filled the encyclopedias. It was taught in the lecture halls, drawn on the chalkboards, printed in the star charts handed to generations of students. For decade upon decade, anyone who asked how Venus turned, or how Mercury turned, received a reply delivered with total confidence and total conviction. That reply was wrong. Not wrong in some small, forgivable detail. Wrong in its very foundation. The planets had been turning all along in ways the confident answer never imagined. And the confidence itself, that comfortable certainty, was precisely the thing that kept the truth hidden in plain sight for the better part of a century. And here is the weight that should settle over you before we go any deeper. The day is the oldest measure our species owns. Long before we counted years, long before we charted the seasons, long before our languages held words for either, our ancestors knew the rising and the setting of the sun. The day is the bedrock of all timekeeping, the unit upon which every other unit is quietly built. Yet on the world next door, the bright planet that hangs in our own dusk and dawn, that bedrock unit runs longer than the year it is supposed to fit inside. The most basic clock in all of nature ticks slower than the calendar it is meant to fill. And we did not discover this in antiquity, nor in the time of Galileo, nor across the long patient centuries of the telescope. We learnt it within the lifetimes of people still walking the earth, from a faint echo that took minutes to come home. An echo that told us the simplest question a child could ask about another planet. How long is a single day there? Has an answer that quietly breaks the meaning of the word. That single question, simple enough for a child to ask, turns out to have 2 answers. Not because the planet is being coy with us, but because the word day was always carrying 2 different meanings folded quietly inside one small sound. Here on Earth, those 2 meanings sit so close together that we have never had any real reason to pry them apart. There is the day you measure against the sun, and there is the day you measure against the distant stars. On our own world, these 2 clocks run so nearly in step that the gap between them is invisible to the unaided eye, a difference of a few minutes that only careful instruments were ever able to reveal. On Venus, that same small gap yawns open into 2 completely different lengths of time, and only by holding both of them in your mind at once does the planet stop being an impossibility and settle into something far quieter, something merely strange. So let us be precise about what a day actually is, because almost everyone carries the wrong definition without ever noticing they hold it. Ask a person to define a day, and most will say it is one full turn of the planet, one complete rotation. That answer feels obvious. And it is wrong. Not entirely wrong, but wrong in exactly the way that matters most for the world we are talking about. The day that governs a human life, the day of waking and sleeping, of light and of dark, is not measured against the stars at all. It is measured against the sun. It is the stretch of time from one sunrise to the next sunrise, from one high noon to the following high noon. And that quantity, the time for the sun to climb back to the same place in the sky, is not the same as the time for the planet to complete one true rotation. Picture why they differ. A planet spins, and as it spins it is also travelling forward along its orbit, sweeping slowly around the sun. By the time it has turned once completely, measured against the fixed and faraway stars, it is also slid a little way along its orbital path. The sun has shifted slightly against the sky, so the planet must turn a little farther still to bring the sun back to where it began the day. For a world that spins in the ordinary direction, the same direction in which it orbits, this means the solar day comes out always a touch longer than the bare rotation against the stars. The planet has to make up that small extra angle. The day you actually live by ends up slightly longer than the day the stars alone would measure. Now invert the whole picture. Venus does not spin in the ordinary direction. Venus spins backward, against the grain of its own orbit, the only large world in the entire solar system that turns the wrong way. And when a planet rotates backward, the arithmetic of the day flips its sign. The orbital motion no longer makes the sun harder to catch. It makes the sun easier to catch. As Venus inches forward along its orbit while rotating in reverse, the sun comes around to meet the surface sooner rather than later. The solar day is not stretched longer by the orbit. It is squeezed shorter by it, and squeezed dramatically. This is the whole reason the two numbers for a Venusian day stand so far apart. Measured against the distant stars, a single rotation of Venus takes 243 Earth days. That is the true spin, the sidereal day, the planet turning once on its axis, with nothing overhead to reference but the cold and unchanging stars. But measured against the sun, the day that any creature standing on the surface would actually feel, the time from one sunrise to the next, is only 116.75 Earth days. Not 243, barely more than 100. The sun returns to its place in the Venusian sky, not after a full rotation of the planet, but after a little less than half of one. We did not reason our way to these numbers from a comfortable armchair. We had to send something out across the dark and listen patiently for the answer to come home. In 1961, as Venus drew near to Earth, radio astronomers aimed concentrated beams of radar at the planet and waited for the faint reflection to crawl back across tens of millions of miles of empty space. A 26-meter antenna at Goldstone in California, operated by NASA's Jet Propulsion Laboratory, the Great Dish at the Jodrell Bank Radio Observatory in England, and a Soviet facility at Yevpatoria in Crimea, all bent their attention onto the same bright point of evening light. The thick cloud deck that had hidden Venus from every optical telescope for 3.5 centuries was no barrier at all to radar. The radio waves slipped through the clouds, struck solid rock, and returned carrying the faint fingerprint of the planet's spin. By 1962, the astronomers had reached a conclusion that no one had expected to find. Venus was turning backward. By 1964, the retrograde rotation was confirmed beyond any doubt, and that strange 243-day figure was fixed permanently into the record of what we know. Consider now what all of this means for anything that might stand beneath those clouds. The sun on Venus does not rise where our sun rises. Because the planet turns backward, the sun lifts up over the western horizon and sinks down toward the east, the exact reverse of every single dawn our species has ever watched from the beginning of our existence. And it moves with a slowness that has no equal anywhere in human experience. From the moment the sun first clears the western edge of the world to the moment it finally vanishes in the east, close to 60 Earth days would quietly pass. The full cycle, one Venusian day joined to one Venusian night, runs a little under 117 Earth days from start to finish. In the span of a single Earth day, the sun would barely seem to move at all. A child could be born on that surface, and learn to crawl, and learn to stand, and the sun would still be hanging in nearly the same patient quarter of the sky. And here is the consequence that finally breaks the calendar itself. Venus completes one full orbit around the sun, one entire year, in 224.7 Earth days. Its solar day, sunrise to sunrise, runs 116.75 Earth days. Divide the one length into the other, and you discover that a single Venusian year contains only about 1.92 solar days. Not 365, not 30, not even a clean 2. Fewer than 2 sunrises in the course of an entire year. A being living out one Venusian year would watch the sun rise, watch it cross the whole arc of the sky across many long months, watch it set on the far horizon, endure the long dark that followed, and then see the sun begin to rise a second time. And before that second day could ever finish, the year would already have ended. Think for a moment about what a calendar would even look like in such a place. On Earth we stack a few hundred days neatly inside a single year and think nothing of the arrangement. On Venus the year is the shorter unit, the day is the longer one. The page simply does not divide. There is no tidy column of dates to fill in, no week, no month that fits cleanly inside the orbit. The most basic rhythm a living thing could know, the plain alternation of light and dark, of sunrise and sunset, happens there not many times in a year, but fewer than twice. Time on Venus does not tick, it looms. And this is where the numbers, for all their precision, fall silent and leave us with a deeper question they cannot answer on their own. We know what Venus does, we have measured it, beam by patient beam, echo by faint returning echo. But we have not yet said why. Why should a planet spin backward at all, turning against the sweep of its own orbit, against the same direction in which nearly every other world was set spinning from the great disk of dust and gas that made them all? Why should it turn so impossibly slowly, more slowly than any other planet in the sun's entire family of worlds? The motion is not some careless accident still waiting for an explanation. It is the visible outcome of a contest, a quiet and almost unimaginably enormous tug of war that has been grinding on across the face of Venus for billions of years, fought between two forces that almost no one would ever think to set against each other. Consider the first of those two forces. The sun reaches across the void and takes hold of Venus the way it takes hold of every world, not with a hand but with the patient, relentless pull of gravity. That pull is not perfectly even. The side of Venus that faces the sun is tugged a little harder than the side turned away, and the difference, small as it is, stretches the planet ever so slightly along the line between the two bodies. The solid rock of Venus, the basalt and iron of an entire world, deforms. It rises into a faint bulge, a swelling in the planet's own body that always wants to point toward the sun. This is the solar solid body tide. It is the same kind of force that lifts the oceans of Earth, except here it works on stone. Now here is the consequence. Because Venus turns, that bulge of rock is carried slightly out of line, dragged a fraction ahead of the sun before it can settle back. And a bulge that is out of alignment is a handle. The sun pulls on it, twisting, trying to wrench it back into place. And that twist acts as a brake on the entire planet. Over spans of time that dwarf the age of every mountain on Earth, this brake should do only one thing. It should slow a world until it turns exactly once for every trip around the sun, until one hemisphere stares into the fire forever and the other faces eternal night. This is precisely the fate Giovanni Schiaparelli imagined when he sketched a Venus frozen in synchronous lock. For most of the small inner worlds of any star system, this is roughly how the story is supposed to end. But Venus did not end that way. And to understand why, you have to weigh the second force, the one almost no one thinks to place on the scale against the gravity of a star. That force is the air itself. Venus does not wear a thin veil of atmosphere the way Earth does. It carries an ocean of gas, an atmosphere 93 times heavier at the surface than the one pressing on your shoulders right now. A blanket of carbon dioxide so dense that the bottom of it behaves less like air and more like a fluid. And the sun heats this enormous mass unevenly. The day side swells with absorbed warmth, the gas expands and lifts and bulges outward, while the night side cools and sinks. This creates a second tide, not in rock but in atmosphere, a moving mountain of heated air. The science describes it as a thermal tide, and it is the strange twin of the solid tide beneath it. Both are bulges. Both are dragged around by the turning of the planet, but they pull against each other. The rock tide is a brake. The atmospheric tide is an accelerator. One tries to stop Venus and lock it to the sun. The other tries to speed it up and tear it away from that lock. Not by a little. Because the atmosphere is so monstrously heavy, the push it delivers is strong enough to stand toe-to-toe with the gravity of a star. This is the contest. Two torques, born of the same sunlight, working in perfect opposition across billions of years. And the slow, backward, almost imperceptible turning of Venus that the radar dishes measured is not a starting condition left over from the planet's birth. It is a result. It is the settling point, the equilibrium where the brake of the rock and the engine of the air come so close to cancelling each other that what remains is only the faintest residual drift. Not stopped. Not locked. Held. Venus turns the way it does not because something set it spinning slowly long ago and walked away, but because two titanic forces are still, at this very moment, leaning against each other with almost exactly equal weight, and the spin we see is the narrow gap between them. There is another possibility, and honesty requires that we name it. Early in its history, Venus may have suffered a colossal blow, a collision with another large body in the chaos of the young solar system, a strike violent enough to knock the whole planet over, or to reverse its spin in a single catastrophic instant. Such an impact cannot be ruled out. The evidence does not forbid it. But here is the quiet elegance of the tidal explanation. It does not need the catastrophe at all. The competing pull of stone and air is enough, all on its own, to produce a world that turns backward and turns slowly. The collision is a story we are allowed to tell, but it is not a story the physics demands. Venus may be strange not because something shattering happened to it, but because nothing did, because it simply sat in the sunlight long enough for two ordinary forces to grind it down to this improbable balance. And then, in 1966, the radar revealed something that turned the strangeness stranger still. As the astronomers gathered their echoes over the years, they noticed that Venus does not show us a random face each time it swings between Earth and the Sun. It shows us very nearly the same face. Every inferior conjunction, every time Venus laps us on the inside track and slides directly between our world and the star, the same hemisphere is turned roughly toward Earth. Those conjunctions come around on average every 584 days, and locked to that rhythm is a rotation period of about 243.16 days, turning backward. This is not quite a coincidence. The leading idea is that Earth itself, our own small and distant planet, reaches across more than 25 million miles of empty space and adds its own faint gravitational torque to the contest. One more hand on the scale already strained between the sun's stone tide and the heat tide of the Venusian air. If that idea holds, then the spin of Venus is not shaped by the sun alone. It is shaped, in some small and astonishing part, by us. Sit with that for a moment, because it is the kind of fact that quietly rearranges your sense of how connected these worlds truly are. The clock on Venus, the impossible clock whose single day outlasts its year, may be set in part by the pull of the very ground beneath you. Not through any signal, not through any intention, but through the oldest and most universal force there is, gravity reaching silently across the dark and nudging a sister world toward showing us her face. The same force that holds you in your chair holds Venus in its slow, reluctant turn. Now imagine standing on that surface, if a body could survive there, and feeling time the way Venus keeps it. Your pulse would mean nothing to this place. Your breath, your heartbeat, every rhythm your body uses to measure the passing of a moment would be absurdly, almost comically out of scale, with a world where the sun crawls across the sky over the course of nearly 4 Earth months. You could be born, grow old, and die many times over before a single Venusian sunrise climbed all the way to noon. The internal clock you carry in your chest, the one that tells you it is morning, that it is late, that it is time to sleep, would have no anchor here at all. On Venus, your body would keep time for a world that does not. It would tick on faithfully against a sky that simply will not move, a small frantic timekeeper, in a place where time itself has been stretched until it lost all human shape. That is the deepest meaning of the contest between the stone and the air. It did not merely slow a planet, it severed the bond between the spinning of a world and the living rhythms of anything that might ever stand upon it. The brake and the engine fought to a standstill, and in the silence of that standstill they unmade the day. The numbers told us what Venus does, and now the forces have told us why. But knowing why does not make the place feel any less alien. If anything, it makes it stranger, because it means this was not an accident at all. It was earned, slowly, force against force, across an expanse of time that has no end in sight. The tug of war is not over. It was never going to be over. It has only, for now, fallen still. But Venus is not the only world that broke the day. It is not even the strangest. There is a second world, closer to the sun, smaller and faster, that keeps a clock that should not exist. Not a clock slowed almost to stillness by a war of tides. A clock locked into a ratio so exact that for most of a human lifetime the finest astronomers alive read it completely backward. That world is Mercury. And to appreciate how unsettling its timekeeping truly is, you have to set aside everything Venus just taught you. Venus broke the day through paralysis. Mercury breaks it through precision. The little planet does not drift, it marches, and it marches to a count so clean it looks almost designed. For every 2 laps Mercury runs around the sun, it turns on its axis exactly 3 times. Not roughly 3, not nearly 3, 3, to the limit of every measurement we have ever made. This is the 3-to-2 spin-orbit resonance. It is the reason a single day on Mercury swallows 2 of its years whole. Hold those numbers for a moment, because they do not behave the way numbers should. Mercury completes 1 orbit of the Sun in 88 Earth days. It completes 1 full turn relative to the distant stars in 58.65 Earth days. You might expect the sunrises to follow the spin. They do not. Measured from the surface, from one sunrise to the next, a single solar day on Mercury lasts 176 Earth days. That is twice the length of its year. The sun crawls across that black sky so slowly that the planet laps it twice in the time it takes to climb once from dawn to dawn. This is the quiet arithmetic of a world where the calendar runs faster than the clock. On Earth, the day is the small unit and the year is the large one. We nest one inside the other without ever thinking about it. 365 sunrises stack neatly into a single trip around the sun. On Mercury, that nesting collapses entirely. The year becomes the small unit. The day becomes the large one. A child born at one sunrise on Mercury would celebrate 2 birthdays before the sun set. For 76 years, the textbook said something else entirely. In the years around 1889, the Italian astronomer Giovanni Schiaparelli, working from his observatory in Milan, studied the faint smudges of detail on Mercury's surface and concluded that the planet was tidally locked. He believed it kept one face turned eternally toward the sun, the way the moon keeps one face turned toward Earth. One hemisphere would bake in endless daylight, the other would lie in permanent frozen night. It was a clean idea. It was also wrong. Not slightly wrong. Wrong in the most complete way an idea about a planet can be. What makes the error remarkable is not that Schiaparelli made it. It is why it survived for so long, defended by careful men with good instruments. Mercury is small and close to the Sun, which means it is almost always lost in the glare. Astronomers could study it clearly only during a handful of brief windows each year, when its position in the sky happened to be just right. And here lies the trap that held them. Those favourable windows recurred on a schedule that fell quietly into step with Mercury's true rotation. So every time anyone looked, the same markings faced Earth. Not because Mercury was holding still, but because the planet had turned an exact whole number of times between one viewing and the next, and presented the identical hemisphere each time, like a dancer who lands in the same pose every time the curtain rises. It was a coincidence dressed as a law. The planet was spinning the entire time, steadily and without pause, and the very rhythm of its spinning conspired with the rhythm of human observation to hide that fact in plain sight. Consider what this means. For 3 generations, our picture of an entire world was built not on what Mercury was doing, but on the narrow slice of moments when we were able to watch, the selection of when we looked masqueraded as a truth about the thing we were looking at. The error was not in the eyepiece. The error was in the schedule. The illusion did not break until 1965. In that year, astronomers turned radar on Mercury, sending a pulse of radio energy across tens of millions of miles of empty space, and waiting for the faint echo to return. The returning signal carried the planet's spin written into its frequency, stretched on the edge turning toward us, and compressed on the edge turning away. When the measurement came back, it overturned 76 years of accepted astronomy in a single stroke. Mercury was not locked. It was turning, 3 times for every 2 journeys around the Sun, exactly as it had been turning all along while we insisted otherwise. But the resonance was only the beginning of the strangeness, and what follows makes the slow, stately day of Mercury seem almost gentle by comparison. Picture yourself standing on a plain near Mercury's equator, on a morning that lasts for weeks. The Sun has just cleared the horizon, swollen and white, far larger in that sky than it ever appears from Earth. You watch it climb. And then, slowly, it stops. For a stretch of Earth days it hangs there, motionless against the stars. Then it begins to move backward. The Sun sinks toward the horizon it just rose from, dips beneath it, and sets a second time. After a pause, it rises again, a second dawn within a single morning, and resumes its long crawl across the sky. A double sunrise, 2 dawns separated by a false sunset, all inside one Mercurian day. This is not a trick of a tired eye, and it is not a story. It is geometry, as certain and as repeatable as the tides. The cause lies in the shape of Mercury's path, and the speed at which it travels that path. Mercury's orbit carries it nearer to and farther from the Sun across each lap, and its speed is not constant along the way. At its closest approach, the point astronomers call perihelion, the planet whips around the Sun at up to 47 kilometers per second, roughly 29 miles in every second. For a brief span near that point, Mercury's racing orbital motion outruns the steady turning of its own surface. The Sun is dragged across the sky by 2 motions at once: the spin of the planet beneath your feet and the rush of the planet around its star, and for a few days the second motion wins. So the Sun appears to reverse, not because anything truly moves backward, but because the planet's headlong sprint around its star briefly overpowers the patient rotation of the ground you stand on. When the sprint eases and Mercury swings back outward, the spin reasserts itself, and the Sun resumes its forward march as though nothing had happened. Sit with how far this carries us from anything human. On Earth, the one direction we never question is the direction the Sun travels. It rises in the east and sets in the west, and it has done so for every dawn of every life that has ever been lived. We build our deepest sense of time on that single unbroken certainty. On Mercury, even that fails. The most basic guarantee of a day, that the Sun goes one way and only one way, dissolves. The sky itself becomes unreliable. There is no fixed direction to the morning, no promise that the light climbing now will keep climbing. And here is what should settle slowly into the chest. Venus and Mercury are not variations on a single theme. They are two entirely separate accidents that arrived at the same impossible place by roads that share nothing. Venus broke its day through a deadlock of tides, a furnace grinding itself nearly to rest. Mercury broke its day through a clean mathematical lock, a marching resonance that turns the sun around in the sky. Different sizes, different distances, different mechanisms, different histories, yet both ended with a calendar where the year is shorter than the day, a thing our entire vocabulary of time was never built to hold. To appreciate how disorienting this truly is, consider the words themselves. We say day, and we mean something small and reliable. We say year, and we mean something larger that contains the smaller. On these two worlds, the words trade places, and the language has no defense against it. The error our ancestors made about Mercury was an error of patience, of not yet having the radar to see the spin. The error buried in our very speech is older and deeper. We assumed the universe would always make the day the smaller thing. It does not. It never agreed to. Return then to Mercury, and watch what its clock does to the sun itself. We have called the resonance clean, a lock of 3 turns for every 2 orbits, a thing radar finally pinned down in 1965. But cleanness in the arithmetic does not promise simplicity in the sky. A Mercurian day, measured from one sunrise to the next, runs 176 Earth days, and that single span of light contains exactly 2 Mercurian years. Within that long crawl, the sun performs a motion no human eye has ever seen from the ground of any world we call home. It slows, it stops, then it turns around and travels backward. The mechanism that produces this is a matter of exact proportion. Mercury turns once on its axis every 58.65 Earth days, and it completes one orbit every 88 Earth days. Set those 2 periods side by side, and a ratio emerges that is almost unnervingly precise. 3 rotations for every 2 journeys around the sun. Not roughly 3, not approximately 2. A lock so close that the planet returns the same patch of ground toward the sun at every other closest approach. A rhythm it is kept far longer than there have been eyes to measure it. It is this exact ratio that hands a point on the equator its long march of light, and it is the racing, lopsided orbit beneath the spin that makes the sun stumble. The reason is geometry, not metaphor. Mercury's orbit is not a gentle circle, but a stretched ellipse, carrying the planet from 58 million kilometers, roughly 36 million miles, inward toward perihelion, its closest pass by the sun. As it swings in, it accelerates to nearly 47 kilometers per second. At that moment, the planet is sweeping around the sun, faster than it is turning beneath it. The orbital motion, which usually helps drag the sun across the sky, briefly overtakes the slow spin entirely. The sun, which had been climbing, hesitates against the black. It halts. Then it slides back the way it came, sinking below the horizon it had only just cleared. A while later it stops once more, reverses a second time, and rises again. A double sunrise. 2 dawns in a single morning, divided by a false and silent dusk. If Mercury orbited the sun on a perfect circle, its speed would never change. The spin would always win, and the sun would cross the sky in one slow but unbroken arc. But Mercury's orbit is far from circular, and so the sun is granted permission to retreat. If you could stand at the right longitude on Mercury's equator, along the narrow band of ground where this alignment unfolds, you would watch it happen with your own eyes. The sun would lift above the eastern rim. It would slow as though unsure of itself. It would stop and hang motionless for a stretch of Earth days, and then sink back down and disappear. The sky would darken toward a night that was not yet owed. And then, with no explanation any earthly instinct could offer, the same sun would climb the same horizon a second time and resume its march toward noon. Not a different star, not an eclipse, not a trick of cloud or shadow, for Mercury has no clouds at all. The same sun, unmaking its own dawn before it would consent to keep it. Hold that image against the one thing our species always trusted the sky to honor. On Earth, the sun's path is the promise that is never broken. It rises in the east, it crosses, it sets in the west. Every calendar we built, every clock we wound, every word we coined for morning and noon and evening rests on that one unbroken arc. We did not invent the day, we inherited it, fixed and faithful, from a star that has not reversed itself once in the entire span of human memory. Mercury extends no such guarantee. There the sun is not a steady hand sweeping forward. It is something that can stall, recoil, and double back, and the rock beneath it must endure both the leaving and the returning. Venus broke the promise one way, sending its sun to rise in the west and set in the east, the whole sky running backward at a funeral pace. Mercury breaks it another, letting the sun stop dead and retrace its steps in the middle of the morning. Two worlds, two separate violations of the single rule we assumed was written into the fabric of things. Neither world consulted our expectations, neither was ever required to. Consider, now, what this slowness does to the ground. A single point on Mercury's equator, caught beneath that lingering, reversing sun, does not receive a passing day's warmth. It receives weeks of it. The solar day lasts 176 Earth days, and Mercury carries almost no atmosphere to draw that heat away or spread it around. So one patch of surface bakes under direct sunlight for the equivalent of months at a time. At the longitudes where the double sunrise occurs, the sun lingers near the high point of the sky even longer, pouring its energy down, withdrawing and pouring it down again before it finally moves on. There is no afternoon cooling. There is no merciful nightfall waiting at the end of an hour. There is only the slow and total gathering of a star held nearly still overhead. This is the cruelty folded inside the clockwork. The resonance that turns Mercury's calendar into a curiosity is the same resonance that turns its surface into a place of extremes the Earth has no language for. A world that spun quickly would share its heat, swinging each face toward the sun and away again within hours, smearing the temperature into something a body might survive. Mercury does the reverse. It pins each hemisphere in the light, or holds it in the dark, for the length of what we would call a season. Not for an hour, not for a day in any sense we were raised to mean, for weeks of unbroken fire, followed by weeks of unbroken and lightless cold. And here the unease turns from a puzzle of words into something with physical weight. The strangeness we began with, a day that outlasts a year, was at first only arithmetic, a trick of definition our vocabulary could not contain. But the arithmetic was never separate from the consequences. A planet that turns this slowly is a planet that cannot shield its own surface from the star it circles. The same unhurried spin that makes the calendar absurd is the spin that lets one side cook while the other freezes, that builds gulfs of temperature across a single small world that nothing alive could bridge. The clock and the furnace are not two facts. They are one machine, seen from two angles. Schiaparelli, sketching the planet through his telescope in the 1880s, saw none of this. He saw a steady, patient face, and he reasoned, sensibly enough for his moment, that Mercury must hold that face toward the sun forever, one hemisphere in eternal day, the other in eternal night. He was wrong, but he was wrong in a revealing direction. He imagined a world simpler than the real one. The truth radar uncovered was stranger than the frozen locked planet he had drawn. The real Mercury does not hold still. It rolls slowly through its resonance, 3 turns for every 2 laps, and in doing so it subjects every stretch of its surface, in time, to both the searing day and the freezing night. There is no permanent refuge on Mercury. The slow rotation does not spare one hemisphere by dooming the other. It dooms all of it, in turn by the same patient clock. If a clock can do this to a planet, the question begins to press inward. What, exactly, is a day when it can stop and reverse in the sky? What is a year when it fits twice inside that single day? These are not yet questions about meaning. They are questions about machinery, about the indifferent physics of mass and orbit and spin that arranges these worlds without the slightest regard for the creatures who would one day try to name what they were seeing. And on the world next door, the bright one wrapped in endless cloud, that same indifferent physics built something even less merciful than a sky where the sun runs backward. Consider what waits beneath those clouds. For most of human history, the order of the planets carried a simple and comforting logic. The closer a world sits to the sun, the hotter that world must be. Mercury rides nearest to the fire. Mercury then should be the hottest place in the solar system. It is a clean intuition, the kind a person arrives at without instruction. And it is wrong. Not wrong by a small margin, the way a careful guess can still miss its mark. Wrong at the root, because it weighs the one quantity that seems to matter and ignores the one that actually rules. Venus orbits the Sun at nearly twice Mercury's distance from the flame. By the comforting logic, it should be markedly cooler, a warm world rather than a scorching one. Instead, Venus is the hottest planet in the solar system, hotter than the sunlit face of Mercury itself, and not by a narrow degree. Its surface holds steady at 737 Kelvin, that is 464 degrees Celsius, or 867 degrees Fahrenheit, a temperature that does not merely scorch but liquefies. Lead would run like water there, zinc and tin would pool into bright puddles on the ground. The surface of Venus is hot enough to melt the metals we use to seal pipes and join circuits, and it holds that heat everywhere, at all times, with almost no variation from the blazing noon to the depth of the long night. This is the turn that recontextualizes everything that came before. The heat of Venus is not a gift of the sun, not in any direct sense, not as a simple matter of proximity to the flame. The sun delivers light to the cloud tops of Venus, but those clouds are bright and reflective, and they turn most of that light away again before it can ever reach the ground. The heat is something the planet does to itself. It is manufactured below, trapped by the air, and refused permission to leave. The engine is not the distance to the sun, but the blanket the planet wears. And the blanket wrapped around Venus is unlike anything a human body was ever built to imagine. Begin with what it is made of. 96.5% of the air on Venus is carbon dioxide. The remaining sliver, roughly 3.5%, is nitrogen, and threaded through the whole of it are clouds, not of water, but of sulfuric acid. Carbon dioxide is a patient jailer of heat. Sunlight that does filter through warms the rock, and the warmed rock radiates that energy back upward as infrared, and the carbon dioxide absorbs it and holds it, and returns it downward again, over and over, a sealed circulation of warmth with nowhere to go. This is the greenhouse effect, the same principle that warms a parked car on a mild afternoon. On Earth, that effect is gentle and life-sustaining. On Venus, it ran away. And here the slow rotation rejoins the story, no longer a curiosity of the calendar, but a partner in the cruelty. On a fast-spinning world, the night offers relief. The surface turns away from the sun, sheds its heat to the dark sky, and cools before morning returns. Venus is denied that mercy, not because its night is short, but because its night is so long that it should by every earthly instinct be a season of deep cold. A point on the Venusian surface waits months in darkness before the sun returns. On Mercury, that same months-long darkness produces a plunge of hundreds of degrees. On Venus, it produces almost nothing. The day side and the night side of Venus differ by only a handful of degrees, because the thick air carries the heat around the planet and hoards it through the dark, and the surface simply cannot cool. The longest night in the inner solar system, on the world with the slowest spin, and it brings no relief at all. That is the cruelty hidden inside the strange clock. The slow rotation does not cool Venus down. It removes the only escape the heat might ever have had. Now stand on that surface, and the second assault begins. It is not the heat alone that would end you, it is the weight of the sky. The atmospheric pressure at the surface of Venus is 93 times the pressure at sea level on Earth. To grasp what that means, do not imagine thicker air, imagine the ocean. That crushing force is what a diver would feel roughly 1 kilometer beneath the surface of Earth's sea, in a darkness no recreational diver will ever reach, where the water itself becomes a slow and grinding hand. A human standing on Venus would not be baked first and crushed second. Both would happen at once, in the same instant, the body pressed by the weight of a kilometer of imagined ocean, while it cooked in heat enough to soften lead. And there would be no seasons to wait out, no spring to hope for. The axial tilt of Venus is only about 3 degrees, almost perfectly upright, so the planet has no summer and no winter. It has only this, the same hell, in every place, through every part of its long and backward day. For decades this was theory, a portrait assembled from distant measurements and inference. Then human machines went down to see for themselves, and the portrait became a photograph. The story of those machines is one of the most quietly astonishing chapters in the history of exploration, because it is the story of building something that knew it was going to die, and asking it only to live a little longer than it should. The first to truly arrive was Venera 7 in December of 1970. It was the first spacecraft humanity ever placed gently onto the surface of another planet, and the first to transmit data back from that surface. It did not last long, and it did not need to. In its brief life, it recorded a temperature of 474 degrees Celsius and a pressure of 90 bar, and in doing so it converted a frightening calculation into a measured fact. The numbers the theorists had feared were not exaggerations. If anything, the reality was worse than the cautious had dared to publish. But the image that would stop the breath came later, on the 1st of March, 1982, when the Soviet probe Venera 13 settled onto the basaltic plains of Venus. It was engineered to survive for 30 minutes. 30 minutes was the promise, the modest hope, the figure its designers wrote down knowing the planet would tear the craft apart soon after. Venera 13 did not honour that figure. It survived for 127 minutes. Not the half hour it was built to endure, but more than 4 times that span, transmitting steadily the entire time, in 465 degrees of heat and 89 Earth atmospheres of pressure, with the equivalent of nearly a kilometer of ocean pressing down on its hull. It was a machine outliving its own death sentence, sending home everything it could see for as long as it could see anything at all. And what it saw, no human eye had ever witnessed. Venera 13 returned the first colour photographs ever taken from the surface of another world. Not a smudge, not a sketch, not an artist's impression assembled from data, but actual colour panoramas of an actual place. They show flat slabs of fractured basaltic rock, broken and layered like cracked paving stones, stretching away beneath a sky stained the colour of a dim and sickly orange. The light there is not the white of an earthly noon. It is filtered through 50 kilometers of acid cloud and dense carbon dioxide until only a heavy amber glow survives to reach the ground. There are no shadows sharp enough to call shadows. There is no horizon you would recognize as a horizon. There is only the dull tangerine light, the broken rock, and a stillness that has held in that exact place, at that exact temperature, for longer than there have been creatures on Earth to wonder about it. Look closely at what that photograph truly represents. It is not merely a picture of a distant planet. It is a portrait taken from inside a furnace by a camera that was already dying, in the last minutes of a life that lasted 4 times longer than anyone had promised it could. Every colour in that frame was sent home across 40 million kilometres of empty space, by a machine being crushed and cooked as it worked. And the place it shows us is not exotic in the way an alien jungle might be exotic. It is exotic in the way a closed oven is exotic. A sealed and lightless room where nothing moves and nothing ever changes, and the temperature never falls. This is the world that slow rotation and a runaway atmosphere built together. The bright evening star that humans have admired since before they had written language. the most beautiful point of light in our sky revealed at last as the most hostile surface we have ever touched. And here is the part that should unsettle most. None of this was inevitable in the way the sun's heat is inevitable. The blistering surface of Venus is not the simple price of orbiting close to a star. It is the outcome of an atmosphere that crossed a threshold and could not come back, of a planet that warmed itself past the point where warming could ever stop. Mercury, naked and airless, suffers the sun directly and honestly, and on its dark side it freezes. Venus suffers itself. It is hotter than the planet nearest the flame, because it learned to keep every scrap of heat it ever made. And that distinction between a world burned from without and a world burning from within is about to matter more than any temperature reading, because it raises a question that follows us home. The question is simple to ask and difficult to live with. If a world can warm itself past the point of return, then heat is not only something a planet receives, it is something a planet can manufacture. And a planet that manufactures its own heat does not need to move closer to a star to become lethal. It only needs to hold on to what it already has. This is the idea that turns Venus from a curiosity into a mirror. Consider what this means. We tend to imagine temperature as a matter of distance. Ask anyone why one planet is hotter than another, and the answer comes without hesitation. The hotter one must be closer to the sun. It is the most natural assumption in the world, and it is built into every childhood drawing of the solar system. The inner planets glowing, the outer planets blue and frozen. That confident answer is wrong, not occasionally wrong. Wrong in precisely the case that matters most. Mercury sits nearest the fire, and yet Mercury is not the hottest planet. Venus, farther out, nearly twice as distant from the sun, holds that title by a margin of hundreds of degrees. The intuition fails exactly where we most expect it to hold. The misconception survives because our bodies teach it to us. Stand near a fire and you are warm. Step back and you cool. Distance and heat feel like the same thing, because in a single room, they are. But a planet is not a person standing near a fire. A planet is a body wrapped in whatever atmosphere it managed to keep, and the atmosphere decides everything. Temperature is not set by how much heat arrives. It is set by how much heat stays. Mercury receives far more sunlight per square mile than Venus ever will, and Mercury lets nearly all of it escape back into space the moment the sun goes down, which is why its night side falls to negative 173 degrees Celsius. Venus receives less and keeps almost all of it. The carbon dioxide that makes up 96.5% of its air acts as a one-way door. Sunlight comes in. Heat tries to leave. The door does not fully open. So the warmth accumulates, year after slow year, until the surface settles at 737 Kelvin, and simply stays there, day and night alike, because on Venus there is barely any difference between the two. This is the distinction that follows us home. Mercury is burned from without. Its heat is a gift from the sun, given and taken back on a schedule the sun controls. Venus is burned from within. Its heat is a possession, hoarded by its own atmosphere, and no retreating sun can cool it. One world is at the mercy of where it sits. The other is at the mercy of what it became. And what Venus became, it may not always have been. Here is the part of the story that no surface photograph can show, because it happened before there was a surface like this to photograph. Many who study these worlds believe that Venus did not begin as a furnace. They suspect that long ago, before its atmosphere crossed the threshold from which it never returned, Venus may have been a far gentler place, possibly even a world where conditions were ones we would recognize as habitable, not a paradise. But not this. Somewhere in its deep past, something tipped. The warming fed the warming. Whatever water it may have held boiled into vapor, and water vapor is itself a heat-trapping gas. So the more it warmed, the more it trapped, and the more it trapped, the more it warmed. There was no single catastrophe, no asteroid, no nearby star gone violent. There was only a feedback that found no flaw. This is what makes Venus more unsettling than any airless rock. A dead world that was always dead asks nothing of us. A dead world that may once have been alive, and that killed itself slowly through a process with no villain in it, asks a great deal. It suggests that the line between a living planet and a furnace is not a wall but a threshold, and that a threshold can be crossed by a world that never intended to cross it. There is a stranger thread still, and it loops back to the very oddity that began all of this. The slow, backward turning of Venus, that single rotation stretched across 243 Earth days, is not merely a footnote to its catastrophe. Some who model the planet's history suspect the two are connected, that the same sluggish, almost frozen spin which makes Venus a day longer than its year may have shaped the way its atmosphere evolved, the way heat moved or failed to move across its face, the way the whole runaway took hold. We cannot say this with certainty. The honest answer is that nobody fully knows, yet the possibility is its own kind of vertigo. The peculiarity we opened with, the calendar that refuses to divide, the planet that finishes its orbit before it finishes one turn, may not be a separate fact from the death of the surface. It may be a branch of the same root. Notice what this does to the comfort we might have taken from Mercury. We looked at Mercury and saw honesty, a world with no atmosphere, no insulation, no secrets, baking on the side that faces the sun and freezing on the side that does not, its 600-degree swing laid bare for anyone to measure. There is something almost reassuring in that nakedness. Mercury cannot surprise you. It has nothing to hide and nothing to hold. Venus teaches the opposite lesson. The danger was never only the sun, the danger was the air. And the air is the very thing a world needs in order to be anything other than naked rock. So the question that follows us home is not whether some distant furnace might one day swallow a planet. The question is quieter and far closer. It is whether a temperate world, comfortably placed, neither too near nor too far, can do to itself what Venus did, whether warmth can become a trap. Whether an atmosphere, the thin envelope that makes a planet livable in the first place, can also become the instrument of its undoing. Venus does not answer that question. It only proves that the answer is not automatically no. We have spent this long looking outward, at a planet whose day outlasts its year, at a sky where the sun rises in the wrong direction, at a surface that crushes and melts and glows a dull furnace red beneath clouds of acid. We came for the strangeness of a clock that will not behave. We are leaving with something heavier. The strangeness was never only about timekeeping. A slow world, and a hot world, and a dead world turn out to be, perhaps, 3 descriptions of a single story, and that story is not finished being told. There are deeper layers still beneath this one, mechanisms that reach down into the rock itself and out across the empty space between Venus and the only world we have ever called home. Begin with the rock, because that is where the answer hides. The mechanism that sets Venus turning at its impossible crawl does not live in the clouds, and it does not live in the velocity of the planet through space. It lives in the way the entire body of Venus is squeezed. The sun does not merely shine on Venus, it pulls on it. And because Venus has substance, because it is a sphere of stone and metal some thousands of miles across, that pull is not even from one side to the other. The near side of Venus is tugged slightly harder than the far side, and the planet deforms, stretches, becomes for a moment not quite a sphere, but a thing drawn faintly toward an egg. This is a solid body tide, not in water, but in mountains. The whole crust flexes, and that flexing has a direction, and that direction has been trying for billions of years to bring Venus to a halt. Consider what that means. A solid body tide acts like a hand laid gently against a spinning wheel. It does not stop the wheel in an instant. It drags, century after century, eon after eon, bleeding away rotation in increments too small to measure in a human lifetime. Left alone, the sun's tidal grip would have done to Venus what it has very nearly done to Mercury. It would have brought the planet into synchronous lock, one face turned forever toward the sun, one hemisphere in eternal blistering day, the other in an eternal night that never ends. That is the natural destination of a slow inner world. That is where the physics points. And yet Venus is not there. Venus turns, slowly, backward, and refuses to stop. Here is the problem. Something is fighting the tide. Something is pushing against the hand on the wheel, feeding energy back into the spin faster than the stone tide can drain it away. And the source of that counterforce is not buried in the planet at all. It is the very thing that makes Venus a furnace. It is the atmosphere, the same dense shroud of carbon dioxide that traps heat against the surface, that holds the temperature at 464 degrees Celsius, that presses down with the weight of 93 Earth atmospheres, also responds to the sun. As the sun heats one side of that thick air, the atmosphere swells and shifts, a vast bulge of warmed gas that does not sit directly beneath the sun but lags, carried along by the planet's own motion. This is a thermal tide, not a tide of stone pulled by gravity, but a tide of air driven by heat. And a thermal tide pushes the other way. Where the solid tide drags the rotation towards stillness, the thermal tide of the atmosphere shoves it back into motion. Two hands on the same wheel, one slowing it, one speeding it, locked in a contest neither can win. The slow retrograde turn of Venus, then, is not a setting. It is a truce. It is the precise rate at which these two opposing forces very nearly cancel, the one bleeding away exactly almost as much as the other restores. Venus does not spin slowly because something decided it should. Venus spins slowly because two titans pull on it in opposite directions and have fought to a standstill, and the standstill happens to leave the planet creeping backward at a pace that takes longer to finish a single rotation than to finish an entire orbit. Take away the atmosphere, and the stone tide wins, and Venus stops. Take away the sun's grip on the stone, and the thermal tide wins, and Venus would spin up. What we see is the balance. What we call the longest day in the solar system is the visible signature of an invisible war. And there is something deeply unsettling buried in that idea, something the everyday experience of a clock conceals from us entirely. A clock on a wall keeps time because we built it to keep time. Its rate is fixed, engineered, permanent within its small mechanical life. But the rotation of a planet is not engineered. It is the outcome of forces, and forces can change, and a balance is the most fragile thing in physics. A balance is not a lock. A lock holds because it cannot do otherwise. A balance holds only as long as the two sides remain matched, and the moment one side weakens, the equilibrium begins to slide. Venus's strange relationship between its day and its year is not a permanent fact of the universe. It is a contingency. It is true now, in this geological moment, the way a stone balanced on a ridge is at rest now. It was not always so, and it will not always be. Now extend that across deep time, and the dread sharpens. The atmosphere of Venus has not always been this thick. The greenhouse that drives the thermal tide has a history, a beginning, a slow runaway swelling over hundreds of millions of years, which means the very force that keeps Venus turning grew into its strength gradually, and could in principle wane again, and that the rotation we measure today is a snapshot of a process still unfolding. The longest day in the solar system is not carved into the planet. It is being held there, moment by moment, by a contest that need not have come out this way, and need not stay this way, not eternal, not fixed, not even, in the deepest sense, stable, merely, for now, balanced. There is a second explanation that scientists cannot fully dismiss, and it is stranger still. Perhaps the torque balance is not the whole story. Perhaps, long ago, something struck Venus, a giant impact, a collision of worlds in the chaos of the young solar system, could in a single catastrophic instant have reversed a planet's spin, flipped it over, set it turning backward against the grain of everything else in orbit around the sun. The honest answer is that nobody can rule this out. The torque model does not require a giant impact to explain what we see. The balance of stone tide against thermal tide is enough, on its own, to produce a slow retrograde turn. But enough is not the same as proven, and the universe is under no obligation to have chosen the gentler explanation. Venus may turn backward because two forces fought to a draw, or Venus may turn backward because 4 billion years ago another world hit it hard enough to stop it cold and start it again the wrong way. We do not know which. We may never know. And now reach outward, past the rock, past the air, across the empty space toward home, because the mechanism does not end at Venus. In 1966, radar measurements revealed something that should not, by any simple reasoning, be true. Every time Venus swings to its closest point to Earth, every inferior conjunction, it presents very nearly the same face toward us. Not a random face, not a different hemisphere each time, as you would expect from a planet turning at its own indifferent pace. The same face, again and again, as if Venus were somehow watching us. The interval between those closest approaches averages 584 Earth days. The rotation that would produce this near repetition is close to 243.16 days retrograde, a value tantalizingly near a resonance not with the Sun, but with Earth. Consider what is being suggested here. The Earth is a small planet, far away, with a gravitational reach that at the distance of Venus is almost nothing, a whisper against the roar of the Sun. And yet the theory holds that this whisper may not be nothing. That Earth's faint and patient tug, applied again and again at each close passage, repeated over countless cycles, may help to hold Venus in this near synchrony, combining with the solar tides of stone and the thermal tides of air to lock the planet into a rhythm that keeps turning the same hemisphere toward us. Not a coincidence, perhaps, not chance. A relationship. The two worlds are bound, besides, by a near resonance in their orbits themselves, the Earth circling the Sun 8 times for every 13 circuits of Venus, the geometry of their dance repeating with an almost mechanical regularity across the centuries. We are not certain. The effect is small, the theory is delicate, and the words that honest scientists use are words like theorized and near and almost. But sit with the possibility, because it is the kind of thing everyday experience can never show you. We stand on Earth and we look at Venus as a bright point in the dawn or the dusk, a separate thing, a stranger across a gulf of stone-cold vacuum, tens of millions of miles wide. And the physics whispers back that the gulf is not empty of influence, that across that distance, with nothing between them but the thin scatter of the solar wind, two planets may be holding each other, faintly, through the long reach of gravity, the slowest spinning world in the solar system, perhaps turning at the rate it does, in part because of the small persistent presence of the only world on which we have ever drawn a breath. Not isolated, not alone, bound by a force we cannot see, to a clock we did not set, across a distance that light itself takes minutes to cross. The strangeness of Venus's day was never confined to Venus. It reaches all the way back to us, and we have only begun to feel the weight of how far down this goes. Consider what it means for the balance to be a balance. The slow backward turning of Venus is not a setting carved into the planet at its birth and held there forever. It is the outcome of a contest. On one side, the Sun reaches across the dense air and the solid rock alike and pulls with its gravitational tide, the same patient kind of pull that long ago turned the near face of our own moon to look forever toward the Earth. And that pull works without rest to drag Venus toward a single frozen pose, one hemisphere held eternally toward the Sun. On the other side stands the atmosphere itself. The thick Venusian air is heated unevenly across that enormous day, and the heated air swells and migrates and shoulders against the rotation, a thermal tide that pushes the planet away from stillness. Two hands on the same wheel, one pulling it towards stopping, one nudging it the other way, and the rate we measure today, 243 Earth days for a single turn against the distant stars, is not a destination at all. It is simply the place where those two hands very nearly cancel. Nearly, not exactly. That is the word that should keep you awake, or perhaps the word that should finally let you sleep, depending entirely on how you choose to hold it. A balance that is only nearly even is a balance that can still tip. Think of everything that keeps its grip on this one slow turning. Not the gravity of the sun alone, though it is enormous beyond comprehension. Not the weight and warmth of the atmosphere alone, though it presses down with the force of the deep ocean. Not the faint and distant tug of the Earth alone, reaching across tens of millions of miles to whisper at the planet once in every 584 days. The rotation of Venus is the sum of all of these at once. A single number standing on top of a hidden argument that has been running far longer than there have been any eyes anywhere to watch it. And the argument is not settled. In 1966, radar found something that no astronomer had any right to expect. Venus, it turned out, tends to show very nearly the same face toward the Earth each time the two worlds draw their closest, at every inferior conjunction. The period of that gentle repetition, 243.16 days, sits hauntingly close to the planet's own rotation against the stars. It is almost as though Venus has been, very slowly, turning to keep one cheek toward us. Not because we matter to it in any way, not because there is any intention anywhere in the whole machinery of the solar system, but because the small gravitational torque of the Earth, almost nothing when measured on its own, may be just enough to lean on the near cancellation of those two giant tides, and coax the long balance into a rhythm that quietly keeps time with our passing. Let that settle for a moment. The slowest spin in the solar system may be tuned, in part, by the third planet from the Sun, and because it is a balance and not a lock, it is also a thing that can change. Across the immense stretches of geological time, the kind of time in which mountains are temporary and whole oceans arrive and vanish, the contest between solar tide and thermal tide need not remain exactly where we find it. The atmosphere could thicken or thin. The output of the sun could drift. The delicate near cancellation that holds Venus at 243 days could shift by some small fraction, and a small fraction is all that it would take to send the number sliding. The strange marriage of the Venusian day and the Venusian year, the impossible calendar in which a planet turns more slowly than it orbits, is not a permanent law of that world. It is a long sentence the planet is currently speaking, and the sentence carries no guarantee of ending the way it began. There is another possibility that physicists keep resting quietly on the table without ever insisting upon it. Perhaps the backward spin was not built slowly by the patient war of tides at all. Perhaps, in the violent infancy of the solar system, something enormous struck Venus and flipped it over, or struck it hard enough to reverse what had once been an ordinary forward turning. The honest answer is that nobody can rule this out. And the honest answer is also that nobody truly needs it. The tides alone can account for the slow retrograde rate, without invoking any catastrophe whatsoever, but the universe is under no obligation to choose the tidy explanation. It remains entirely possible that the reason a day on Venus outlasts a year on Venus is a collision so ancient that its scar has long since been swallowed by lava and pressure, and the relentless smothering of that atmosphere. And what an atmosphere it is, to hide so old a wound beneath itself. 96.5% carbon dioxide, with very nearly all of the small remainder being nitrogen, pressing down upon the surface with a force you would only otherwise meet roughly 1 kilometre beneath the waves of an earthly sea. A blanket so total that it has driven the ground to 737 Kelvin, 464 degrees Celsius, 867 degrees Fahrenheit, a heat that does not so much as flicker across the slow march of that endless day. On almost any other world, a day this long would mean a savage swing between scorching light and bitter dark. On Venus, the atmosphere has stolen even that. The day is long, and the length does not matter, because the thick air carries the warmth around the entire globe and holds it there, the lit side and the unlit side alike, inside one single unbroken furnace. This is what a slow world becomes when it can no longer let go of its own heat. And so, we arrive at the strangest weight of all. The number that first opened this journey, the day that outlasts the year, is not some isolated curiosity sitting safely upon a distant planet we will never touch. It is the visible tip of a hidden machinery that runs on gravity and heat and deep time, a machinery in which the Earth itself is quietly a participant. Across the empty miles, our world leans upon that slow turning. Across the same empty miles, the slow turning answers back, not in any way you could ever feel standing in your own garden at first light, not in any way that will alter your own day or your own year by even a heartbeat, but in a way that the mathematics insists is utterly real, that the radar has already measured, that the long arithmetic of orbital resonance confirms again and again. The Earth circles the Sun 8 times for every 13 times that Venus does, a pattern lying so close to perfect that it forms a kind of slow and silent gearwork between the two planets, ticking out the very same near alignment over and over across the centuries. And Venus, the slow one, is not even entirely alone in its corner of that dance. In the year 2024, astronomers gave a name to a small companion that travels alongside it, a quasi-satellite they chose to call Zuzva, a fleck of rock somewhere between 200 and 500 meters across, no larger than a single modest hill, looping the Sun on a path that keeps drawing it back toward Venus, lingering near it in a loose and temporary partnership before wandering away once again. A world that turns more slowly than anything else we have ever known, leaning faintly on the distant Earth, trailed by a nameless hill of stone we have only just learned to call by any name at all. The longer you look at the simple fact, the day that is longer than the year, the more hands you discover resting upon it. Because here is the thing that everyday experience can never once let you feel. None of this is fixed. The balance can tip, the companion can wander, and the Sun, which holds every part of it together, is itself slowly changing across spans of time so vast that the longest human empire would not register as a single tick, which means the impossible calendar we have been turning over together was never meant to last, and the question of what becomes of it goes deeper still than the loss of a single companion or the slow fading of a distant star. It reaches all the way down to the simplest question we have not yet dared to ask. Why does Venus turn at all? We have spent our whole time together treating the day that outlasts the year as a fixed feature of the planet, a number stamped into Venus at its making and carried unchanged ever since. That picture is comforting. It is also wrong. The slow backward turning of Venus is not a property the planet owns. It is a balance the planet is holding, moment by moment, against forces that would gladly stop it. This distinction matters enormously, because a spinning world feels like the most settled thing in the sky. We imagine each planet as a flywheel set turning at the birth of the solar system, coasting ever since through frictionless dark, keeping its own time forever. For most worlds that picture is close enough to the truth. Venus is the exception. Venus is not coasting. Venus is being pulled in two directions at once, and its impossible calendar is simply the place where the pulling reaches a draw. The first hand belongs to the Sun. Gravity does not act on a planet as though it were a single point. It pulls hardest on the near side and weakest on the far side, and the difference stretches the whole world into a faint egg shape, raising a slow bulge of solid rock that always tries to point toward the Sun. As the planet turns, that bulge is dragged a little out of line, and the Sun's gravity hauls back on it, breaking the spin. Given enough time and nothing to oppose it, this tide of stone would do to Venus exactly what Giovanni Schiaparelli imagined from his telescope in Milan, around the year 1890. It would drag the planet down into a synchronous lock, one face held toward the Sun forever, the day and the year finally fused into a single endless thing. But something opposes it. And here is the part that ties every thread we have followed into one knot. The thing that keeps Venus turning is the very thing that makes Venus a hell. Consider what the Sun does to that thick shroud of air. It heats it. 96.5% carbon dioxide, 93 times the pressure you feel standing at the edge of the sea. and all of it soaking up sunlight on the day side and swelling outward. This heated atmosphere forms a bulge of its own, but a bulge offset from the gravitational one, riding ahead of the slow rock beneath it. And that displaced mass of hot air pulls on the planet too, but in the opposite sense. It is a thermal tide, and it does not break the spin, it drives it. The same dense atmosphere that bakes the surface to 464 degrees Celsius, hot enough to melt lead and tin and zinc, is also the hand pressed against Venus's back, pushing it to keep turning when gravity alone would have stopped it long ago. So the furnace and the calendar are not two separate stories, they are one story told twice. Strip away the crushing atmosphere and Venus cools, and the thermal tide vanishes, and the solid tide wins, and the planet locks. Keep the atmosphere and the surface roasts, but the world goes on turning, slowly, backward, against the grain of everything around it. The very air that would kill any visitor in seconds is the reason the day exists at all. This is the disturbing reality at the bottom of the impossible calendar. The slow retrograde rate we measure today is not a destiny. It is an equilibrium. It is the precise point where the breaking pull of stone and the driving pull of heated air very nearly cancel, leaving only a thin residue of motion. The slowest spin of any planet in the solar system. Picture two evenly matched wrestlers, locked arm to arm, neither one giving ground. From a distance they look perfectly still. That stillness is not peace. It is the visible surface of an enormous strain, and the smallest change in either wrestler decides everything. Take a little heat away, or add a little, and the balance shifts. The point of cancellation moves, the day grows longer, or shorter, or surrenders entirely. And the talks do not only come from the sun. In 1966, radar astronomers found something that should not, by any simple reckoning, be there. Every time Venus swings closest to Earth, at the moment we call inferior conjunction, it turns very nearly the same face toward us. Not a coincidence of a single pass, but a pattern that repeats, conjunction after conjunction, across the 584 Earth days that separate one close approach from the next. To hold that pattern, Venus would need to complete its strange rotation in close to 243.16 days, a period tuned not to the sun, but to us. Understanding why requires sitting with an idea that borders on the unsettling. The pull of Earth on Venus is faint, almost beyond description. We are tens of millions of miles away, a small world reaching across a gulf of vacuum. And yet, the theory holds, that faint and patient tug, added to the great contest between solar gravity and Venusian air, may be one more hand resting on the balance, helping to decide exactly where the equilibrium falls. If that is true, then the reason Venus shows us the same face each time we pass is partly that we ourselves, simply by existing in our orbit, have whispered to its spin across the empty dark. The day that is longer than the year may carry a faint fingerprint left by the very planet from which we first learned to measure it. The honest answer is that we cannot yet be certain of all of this. The torque model is elegant, and it explains the slow backward spin without needing anything dramatic to have happened. But it is not the only possible history. A great collision early in the life of the solar system, a blow large enough to tip a world over and set it turning the wrong way, cannot be ruled out. Perhaps Venus was struck. Perhaps it simply drifted into this balance over billions of years of gentle tides. Perhaps both played a part. We have read the rotation with radar, we have measured it to a fraction of a day, and still the question of why it turns this way and not another remains partly open. That is not a failure. That is the shape of an answer still being written. What we can say with certainty is the part that should keep you turning the idea over long after the words have stopped. Nothing here is permanent. An equilibrium is not a lock. It is a truce, and truces can end. The atmosphere that drives the thermal tide is not a fixed quantity poured into the planet once and sealed away. Atmospheres evolve. They thicken and thin across ages. They bleed slowly into space. They are reshaped by the slow changes of the star that warms them. Change the air, and you change the hand pressing on the spin. Change the spin, and you change how the planet meets the sun, how its heat is spread across the surface, how long each scorching day and each long night endures. The mathematics become even more striking when you let go of the human habit of treating today's numbers as eternal. The 243 days of rotation, the year of 224.7, the delicate near match with our own passes, all of it is a snapshot of one instant in a story spanning billions of years. We have caught Venus in a single frame and mistaken it for the whole film. The balance that holds the calendar in place was reached over an immensity of time we can barely name, and it will be lost again over a stretch just as vast. We happen to be alive in the narrow window when the spin sits where it sits, not because the universe arranged that window for us, but because every observer, on every world, only ever sees the frame they were born into. Here is the thought that waits at the end of this final layer, the one that turns the wonder cold. We have been telling ourselves a story about a strange and distant planet, a world where the day outlasts the year and the sun climbs out of the west. We have treated it as an oddity, a curiosity safely far away, a problem belonging to Venus and not to us. But the forces at work there are not exotic. They are gravity and heat and the slow drift of an atmosphere beneath a changing star. They are the same forces that govern every world with a sky, including the one beneath your feet. Venus is not a freak. Venus is a demonstration. It is what these ordinary forces can build when they are given enough time and a thick enough blanket of air, and there is nothing written into the laws of physics that marks one planet as the exception and another as the rule. So the impossible calendar stops being a thing that merely happened to Venus, and becomes a thing that physics is always capable of doing, anywhere to any world, given the right balance of tides and the patience to wait. And that shifts the question one final time. We began by asking how a single day could possibly last longer than a year. We can answer that now. The deeper question, the one that opens quietly beneath us as the solid ground of this whole inquiry begins to give way, is no longer about a planet at all. It is about time itself, and about what a day and a year even are, once you step far enough back to see that the universe never promised to keep them in any particular order. But before we step away from the physics entirely, there is one more thread to follow, and it does not lead outward into the cold and the dark and the indifferent machinery of distant suns. It leads home. It leads to us. Venus and Earth are not strangers passing in the night. They are partners caught in a slow, precise dance that has been running for billions of years. Earth completes 8 orbits around the Sun for every 13 orbits that Venus completes. This is not an exact ratio, but it is remarkably close enough that the two worlds return to nearly the same arrangement again and again across the centuries. Astronomers call this a near-orbital resonance, a 13-8 rhythm written into the geometry of the inner solar system. The pattern is almost musical. Two planets keeping time with each other across tens of millions of miles of empty space. The two worlds draw near one another roughly once every 584 Earth days. This is the synodic period, the interval between one inferior conjunction and the next, the moment when Venus slides directly between the Earth and the Sun. And here is where the dance becomes uncanny. In 1966, radar measurements revealed something that should not, by any obvious logic, be true. Every time Venus reaches that point of closest approach, it turns very nearly the same face toward Earth, the same hemisphere, pointed at us, as if the planet were nodding to a partner it cannot see. Consider what this means. Venus has no reason to care about Earth. Earth is a small world far away, with only a faint sliver of the Sun's gravitational authority. And yet the timing works out so cleanly that scientists proposed an extraordinary idea. The retrograde rotation of Venus, the one that takes 243.16 Earth days to complete, might be held in place partly by Earth itself, not by the Sun alone, not by the thick crushing atmosphere alone, but by the faint persistent tug of our own planet, reaching across the void at every close encounter, nudging Venus back into step. This is the tiny hope buried inside a cold story. The idea that worlds are not truly isolated, that gravity, the weakest of all the fundamental forces, is also the most patient, and that given enough time, even a whisper of it can shape the spin of a planet far larger than the thing doing the whispering. Earth may have reached out, silently, over the entire age of the solar system, and helped to set the rhythm of its neighbour's impossible day. We are not separate from the sky. In some small way, we are written into it. But the comfort does not survive close inspection, because this resonance, like the torque balance that keeps Venus spinning backward, is not a law. It is a coincidence that physics has not yet undone. The 13:8 ratio is near, not exact. The Earth's synchronous nod is approximate, not locked. These are not the rigid certainties of a clock. They are the temporary agreements of bodies that are still moving, still drifting, still slowly trading energy with one another across geological time. Venus is the slowest rotating planet in the entire solar system. Nothing else turns so reluctantly. And the forces that made it that way have not finished their work. They are still acting, still pushing and pulling, still seeking some final balance they may never quite reach. Even the space around Venus is restless. In 2024, astronomers confirmed a small companion travelling alongside the planet, a quasi-satellite given the name Zuzva. It is not a true moon. It orbits the Sun, not Venus, on a path that causes it to linger near Venus for a time before wandering away again. It measures perhaps 200 to 500 meters across, smaller than many city blocks, a fragment of rock keeping loose and temporary company with a furnace world. Even the nearest thing to Venus is only passing through, and here is the thought that quietly closes the door on any final comfort. We have spent this entire journey treating the Earth day as the fixed ruler, the steady unit against which every strangeness is measured. 243 Earth days, 88 Earth days, 176 Earth days. The Earth day has been our anchor, our constant, the one thing in the story that does not move. But the Earth day is moving too. Our planet's rotation is slowing. The Moon, through the gentle friction of the tides it raises in our oceans, is stealing rotational energy from the Earth, a little more with every passing century. The length of our day is growing by roughly 1.4 milliseconds every 100 years. It is an almost invisible change. Across a single human life it amounts to nothing you could ever feel. But across the deep time we have been speaking of, the time in which Venus arrived at its impossible calendar, it becomes enormous. The days of the dinosaurs were shorter than ours, the days of the first living things on Earth were shorter still, and the days of the far future will be longer than any we have ever known. So even our anchor drifts. Even the ruler we have been measuring with is changing length in our hands. There is no day, anywhere, that the universe has agreed to hold perfectly still. And this is where the ground we have been standing on finishes giving way. We came looking for a single curiosity, one odd planet where the calendar runs backward against the day. We found instead that the curiosity is everywhere. The slow drift of Venus, the locked stride of Mercury, the resonant nod between two neighbouring worlds, the patient theft of the Moon. These are not exceptions to some orderly cosmic schedule. They are the schedule, or rather, they are the absence of one. A day is not a unit handed down by nature. It is a local accident, the particular rate at which one particular lump of rock happens to be turning at one particular moment in a history of constant change. A year is the same. And the comfortable assumption that a day must somehow be shorter than a year is not a rule of the universe at all. It is a habit of one planet, held briefly, in one corner of one galaxy, among hundreds of billions of galaxies, none of which were consulted when we decided how time ought to behave. We have answered the question we began with. We understand now how a day can outlast a year, on Venus, on Mercury, and in principle on countless worlds we will never name. But the understanding does not settle us, it loosens something instead. Because once the day and the year come apart, once they stop being fixed and start being merely local, a much older and much quieter question begins to surface beneath them. It is no longer a question for astronomy. It is a question about what time is and whether it was ever ours to keep. Consider what it means to keep time. To keep time is to count something that repeats and to trust that the repetition will hold. The swing of a weight on a string, the slow fall of sand through a narrow waste of glass, the turning of a world beneath a fixed and distant star. We did not invent time, but we invented the counting of it, and somewhere in the long human history of that counting, we began to mistake the count for the thing itself. We built our whole sense of order on two repetitions we assumed would always agree: the day, which is the turning, the year, which is the journey around the sun. And we assumed, without ever quite choosing to, that the first would always fit neatly inside the second, many times over, the way hours fit inside a day. Venus does not honor that assumption. There, a single rotation takes 243 Earth days, while the journey around the sun takes only 224.7. The turning outlasts the orbit, and because Venus spins backward beneath that orbit, the sun completes its slow march across the sky in 116.75 Earth days, so that a single Venusian year contains fewer than 2 sunrises. Not a dozen, not even 3, fewer than 2. Imagine a calendar with no weeks, no months, barely a pair of dawns to mark the passage of an entire orbit. The most basic human time unit, the day, simply refuses to divide into the next unit cleanly. It does not fit. It was never built to fit. It only fits on Earth, and only here, and only now. This is the quiet undoing at the center of everything we have followed. The day and the year are not two sizes of the same thing. They are two entirely separate motions that happen, on our world, to fall into a convenient ratio. One is the spin of a body on its axis. The other is the long fall of that body around a star. There is no law that binds them. There is no cosmic clause requiring a planet to rotate faster than it revolves. We assumed there was, because every sunrise of our lives arrived inside a year that held 365 of them, and the pattern felt less like a coincidence and more like a promise. It was never a promise. It was an accident of how fast one particular rock happens to turn. Mercury makes the same point with a different and stranger arithmetic. There, one solar day, one full passage from sunrise to sunrise, lasts 176 Earth days, and that span is exactly 2 Mercurian years of 88 Earth days each. Sit with that ratio for a moment. On Mercury, the calendar and the clock do not merely disagree. They run in perfect, locked, inverted step. 2 birthdays would pass before the sun finished crossing the sky a single time. A child there would be 2 years old before living through one complete day. No civilization that ever raised a temple to the dawn would have known how to build a calendar around a world where the day is twice the year, where to live one morning to the next is to age by 2 full orbits. Our timekeeping was not designed for this. It was designed for the one place that gave us our intuitions, and our intuitions do not travel. So we are left holding a question that astronomy can describe, but cannot resolve. Is time something woven into the fabric of the universe? Something that exists out there independent of us, waiting to be measured by whatever clock we bring to it? Or is the time we actually live by, the time of days and years and the comfortable expectation that one nests inside the other, nothing more than a story Earth told us, true here and meaningless 3 planets over? Perhaps both things are so. Perhaps there is a deep and genuine time, the steady ticking of physical law, and the day and the year are merely 2 of the many faces it can wear, no single face more honest than another. Or perhaps the day and the year, as we feel them, as we mourn and celebrate by them, were never properties of the universe at all. Perhaps they were always properties of us, projected outward onto a cosmos that spins and orbits in countless ratios, and was never once consulted about which of them ought to be called a day. These questions have no universal answers. Different minds, standing under the same indifferent sky, will reach for different conclusions, and none of them can be proven wrong by a telescope. The astronomer can tell you precisely how long Venus takes to turn. The astronomer cannot tell you whether that turning deserves to be called a day, or whether the word itself is a kindness we extend only to our own planet. That decision is not in the data, it is in you. You are the one who decides what to make of a world where the morning arrives less than twice a year, where the sun rises in the west and crawls across the sky for the better part of an Earth season before it sets again. You can call it alien and turn away, or you can let it loosen the grip that your own ordinary days have always held on your sense of what time must be. And there is something almost merciful in that loosening, if you let it work on you slowly. We carry our days like a debt. We measure our lives in them, count them backward and forward, dread their running out. We speak of having time, spending time, losing time, as though time were a substance held in the hand, a fixed allotment ticking down at one true and universal rate. Venus says otherwise. Mercury says otherwise. They say that the rate is not universal at all, that the very length of a day is a local arrangement, set by how fast a particular world happens to be turning at a particular moment in a history of slow and ceaseless change. The day is not a unit handed down from the structure of reality. It is a measurement taken off the back of a spinning stone, and the stone can spin at any speed the forces acting on it allow. Even the forces are not fixed. Venus holds its strange, slow backward rotation not because it is locked there forever, but because two great influences very nearly cancel. The sun's gravity pulls through the solid body of the planet, dragging it toward a frozen synchronous lock, one face turned eternally starward. And the thick atmosphere, heated and pushed by that same sun, drives a thermal tide in the opposite direction, hurrying the spin away from stillness. The rotation we measure today is the truce between them, the place where the pulling and the pushing meet and hold. But a truce is not a law, it is a balance, and balances shift. Over the deep span of geological time, those talks could drift out of their delicate cancellation, and the relationship between Venus's day and Venus's year, the very impossibility we have spent all this time tracing, could quietly rearrange itself into something else entirely. Venus's calendar is not eternal. It is only the current verse of a song the planet has been slowly singing for billions of years. That impermanence reaches further than the calendar. Venus may once have been a gentler world, before its atmosphere thickened into the crushing, lead-melting furnace it is now, before the greenhouse warming fed upon itself and became unstoppable. The same slow rotation that scrambles its days into fewer than 2 per year may have played its own part in how that atmosphere evolved, how the heat gathered and stayed, how a planet that might once have held water became a place where the surface glows in the dark. We will likely never know the full story, but the suggestion alone should give us pause, because it means the strangeness of Venus's time and the hostility of Venus's surface may be two branches of the same history. The clock and the climate, tangled together, written by the same long forces, neither one of them guaranteed, neither one of them permanent. This is what the question opens onto. Once the day and the year come apart in your hands. Not a tidy fact about 2 planets, not a piece of trivia to be filed away and forgotten by morning, if morning still means anything after all of this. It opens onto the realization that time, the most intimate and inescapable thing we know, the medium we are made to swim in from the first breath to the last, may not be one thing at all. It may be many things wearing a single name, a name we inherited from a planet that happened to give us a rhythm we found livable. Our hours, our days, our years are the music of this one world, and we have spent our whole existence assuming it was the music of the universe. It is not. The universe keeps no single time. It keeps 100 billion times at once, on 100 billion worlds, each turning at its own pace beneath its own star, and ours is only the one we were lucky enough, or unlucky enough, to be born beneath. And so we are left holding a strange inheritance. Perhaps that should unsettle us. Perhaps the discovery that our days and our years are local accidents, true only here, true only for now, should leave us a little unmoored, adrift in a cosmos that owes our clocks nothing and our calendars even less. Or perhaps it is the most quietly freeing thing a person can learn. The day was never a law written into the fabric of things. It was always a gift, handed to us by a spinning ball of rock and water that happened to turn once while we slept, once while the light came and went. We did not invent the rhythm, we were simply given it. A pace to a life, drawn from the turning of a world that never asked our permission, and never will. And to know that it could have been otherwise, that on Venus it is otherwise, makes the rhythm we carry feel less like a cage and more like a small and impossibly precious coincidence. These are not questions that physics can answer for you. The radar dishes measured the spin, the probes recorded the heat, the equations balanced the warring tides, but none of them can tell you what to feel when you learn that a single day can outlast an entire year, that on one world the sun rises in the west, that on another it can climb, halt, slide backward, set and rise a second time before the long day is done. Different minds will sit with this differently. Some will find it lonely, some will find it unbearably beautiful, some will simply close their eyes and let the strangeness move through them like a slow tide that asks for nothing in return. There is no correct response to a universe this vast and this indifferent. There is only your response, and it belongs to you alone. It is the one piece of all this vastness that no instrument can ever take from you. Consider, one final time, where you actually are. You are standing on a single turning world, one among the countless worlds scattered through this galaxy. And this galaxy is only one among the countless galaxies strewn across a universe so wide that no human mind has ever truly held its measure. Venus turns once every 243 of your days, more slowly than any other planet we know, so slowly that it completes its journey around the sun before it completes a single turn upon its axis. Mercury counts off 2 of its long years for every one of its days, and these are only the neighbours, the 2 worlds nearest our own, close enough to touch with radar and to reach with our small brave machines. Beyond them lie distances we have no instruments to measure and no language built to hold. And yet here is the quiet wonder buried inside all that cold immensity. The same slow turning that helped ruin Venus, that helped seal it beneath an ocean of burning air, may once have belonged to a gentler world, in an age before its greenhouse effect closed around it like a fist. Worlds change, spins drift. The delicate balance of forces that holds Venus in its backward crawl is not a permanent lock, but an equilibrium, a fragile truce between competing tides that could, across deep time, be broken and remade. Even our own Earth is slowing, surrendering roughly 1.4 thousandths of a second from each day with every passing century, its rhythm bending so gently that no single life could ever feel it. Nothing about time is fixed. Nothing about it is finished. The story of how worlds keep time is not a closed book but an open one, still being written, on Venus, on Mercury, beneath your own feet, in the slow imperceptible lengthening of the very day you are living through right now. You will sleep tonight, measured by a clock that no other planet shares. You will wake to a sunrise climbing out of the east, on schedule, the way it always has and the way you have always trusted it to. And that ordinary turning, that small reliable miracle you have never once had to think about, is rarer and stranger and more fragile than you ever imagined. The universe keeps 100 billion times, but this one, this single slow turn beneath your own familiar star, is the one that is yours.